So good morning. So today we are going to discuss Unit 2. Okay, we are going to discuss about Unit 2, in which we are going to see one of the layers among OSI layers. We have OSI model in which we have 7 layers, out of which we discussed about physical plus data link layer as part of Unit 1. Okay. Now we are going to discuss the other layer, that is network layer as part of Unit 2. So we will concentrate network layer from second unit onwards. So what does it contains? What type of connections will be there? What are the responsibilities of this layer and what it can do? How the communication can be established and what sort of networks will be considered? What is subnetting? Okay, all these things will be discussed as part of this network layer as part of our syllabus, Unit 2. So coming to Unit 2, we have network layer, as I'm showing here PDF also. So under this, first topic is logical addressing. It is nothing but IP address. Try to understand here. The logical address is nothing but IP address. So in a network, an IP address is of 32 bits of size. Yes or no? According to the basic IP addressing scheme, we will be using 32 bits for every system to allot an IP address. So we can say that every IP address is of 32 bit. When we come across IPv4 scheme, okay, 32 bits. So in the lab session, one of the lab sessions, I discussed about different classes of IP addresses. So class A, class B, class C, and we have class D and class E. We will not discuss much about those things. We will be discussing about more about class A, class B, and class C. So according to the class A, the IP address, so every IP address is divided into 32 bits. Every IP address is of size 32 bits, and the 32 bits are divided into 4 octals, 8 bits each. So according to the class A, 8 bits will be network ID according to class A, and remaining 24 bits will be host IDs. Okay, remaining 24 bits will be remaining 24 bits will be host IDs. Now coming to the class B, So how many bits will be the network IDs here? 16 bits will be network ID, and remaining 16 bits will be host IDs. Okay. So this is about different types of classes where the IP addresses are classified. Okay. So what about the class C? Okay. What about class C? So here under class C, we have 24 bits of network IDs and 8 bits of host IDs. Okay. So this is what we are going to discuss, that is logical. As part of logical addressing, we will be discussing about IP address more. So IP addresses are divided into different classes: class A, class B, class C, class D, and class E. Because we are not discussing class D and class E, so they are not dividing the IP addresses into network ID or host ID. They are not dividing them. So that's why we are not concentrating on these two things right now. Okay. Now coming to this class A, class B, and class C. Class A, according to the class A, 8 bits we used for network IDs, and remaining 24 bits will be host IDs. Host IDs are nothing but the systems which are added to each network. Okay. For each network, let me do this. Okay. See, as I told you, class A is of 8 bits and 24 bits. Okay. This is network ID. This is host ID. Okay. So there are 8 networks are there. Let us say that this is the first network. So out of this first network, there will be 24 addresses will be allotted. That is 24 bits. 2 power 24 bits. Okay. Now coming to the 2 power 8. 2 power 8 network IDs are there. 2 power 24 bit IP addresses are there. So 2 power 8 means how much? 2 power 7 is 128. 256 network IDs are possible. Okay. So every network, out of this, every network, there will be 2 power 24 bits of host IDs will be there. So this is what IP address according to the class A division. Now coming to this PDF. So IP address according to IPv4 addresses, it is of 32-bit address that will be unique and it will be universal, which is used for connecting a device to the internet. So what do you mean by this? It is unique means IP address will be unique for every system or every device which is connected to the internet, and it will be universally connected. It means it has no restriction that it can go to any type of a network, it can access any type of a network. Either it may be a local network, either it may be a remote network or either it may be any other kind of a network. It does not depend on the location of the device where it is located. So universal is nothing but we can access the device which is connected to the internet, that IP address will be accessed universally, means anywhere in the country, out of the country also. Okay. Now coming to this, just now I told you IPv4 address is of 32 bits long and it is also unique and universal. So what is this actually? 2 power 32 address space. Okay, let me concentrate on this point. So what we are discussing, this is address space of IPv4 is 2 power 32 of, that is, just now we told according to the IPv4 addressing 32 bits are needed for assigning an IP address to a device. So 32 bits means 2 power 32 equals to 4294967296. Okay, these many systems can be added. Okay, so this is the address space. Address space is nothing but number of hosts which are involved according to this IPv4. So these many hosts will be included as part of IPv4. So that is the space, address space, which is allotted for IPv4, 2 power 32 bits. Okay. So coming to this next point, you observe here one of the example which is given over here. See, I am not discussing about class A, class B, class B division, how it has been made. I already explained this in the lab session itself. So according to this IPv4 addressing, actually IP addressing is done in two ways. First one, so there are two ways of representing the IP address, that is binary representation as well as dotted decimal. Okay, dotted decimal representation, binary representation and dotted decimal representation. So let us say that if we have an IP address, just now you are able to see on the screen, that is this one, something like this, 128.11.3 point, sorry, point, it is not point, dot 31. Okay, so according to the binary, this is dotted decimal representation, what I wrote here, 128.11.3.31. So every, see, 32 bits are divided into 4 octals. This is the first octal, this is the second octal, and this is the third and fourth one. So every octal contains, octal means 8 bits. So, or octal. So how binary representation will be done? So let us see here. To represent this dotted decimal number in the binary representation, just we have to write 1000 4 bits. This is 8 bits. This is the first octet. Okay. 10000000. This is first octet. Now coming to the second octet, what is the value here? 11. So what is the value? That is 000 0 4 zeros 1011 is 11. Okay, this is 128. Now coming to this one, 00000011. This is 3. Now coming to this one, 0, 0, 0, all ones, remaining ones. 1, 2, 3, 4. Okay. So to represent this address, which is 128.11.3.31, that will be written something like this, that is all at once, that is 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 1, coming to the next one, that is 0, 0, 0, and 0, 0, double 1, coming to triple 0, 1, 1, 1, 1, 1. So this is what the IP address of a particular device. So this is hard to remember. Zeros and ones, it is hard to remember and hard to know what is the signals they can be approached. So what is happening? Instead of using binary representation, we are using dotted representation. So by placing first octet, after first octet, we are placing a dot. Similarly, second octet dot. Similarly, third octet dot. So this is what happens. This is 128, 11, 3, 31. So this is binary representation of an IP address. This is dotted decimal representation of IP address. This is what mentioned here in this diagram. So this is one example. Okay, you observe here in these examples. First one is 1011. See, what is the question here? IPv4 addresses from binary to notation to the dotted decimal notation. So similarly, you have to change this one. So first one is 10000001. Second one is 00001011. Now coming to the next one, 0000. The first question, we are solving the first question and coming to the remaining 1111. Okay, so this will be, what is the value here? So how to know the values here? We will be writing in powers of 2's. So 1, 1, 1, 0, 1, 1, 1, 1. We are discussing about the fourth one. That is 2 power 0 here, 2 power 1 here, 2 power 2 here, 2 power 3 here, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Okay, what will be the value here? 1 plus 2 plus 4 plus 8 plus 0 plus, what is this? 32. Yes or no? 32. 2 power 5 is 32. Yes or no? 2 power 4, 8 to the 16. 16 to the 32. 16 to the 32. 16 3 is 40. Plus, what is the value of 2 power 6? And what is the value of 2 power? That is 2 power 64. This one. Plus 2 power 7 is 128. Okay, while we add this all these numbers, we will get one value, that is 239. Okay, that is the value 239. So 239 decimal number, and here it is 11, and here it is 11, and coming to this one, this is 128 and this is 1. So 128 plus 1 is 129. So what will be the value here? What is the IP address? The IP address is, according to the first question, that is 129.11.11.239. This is the solution for this one. Okay, so similarly this is the second one. So all ones represents what? All ones. All ones in the sense Here 16 will be there. 239 plus 16 is 255. So 255 is a number which is written here. So this is the last one. Here you have 27. Here you have 131. This is 128 plus 1 plus 2 plus 3. 128 plus 3 is 131. This is 128 plus 64. 192 plus 1, 193. So this is one example where we are trying to change the binary number to binary representations to the dotted decimal representation. Similarly, you can also change the decimal notation to the binary notation also. So this is what dotted decimal to the binary representation, second example. So you observe here from this example, see I am giving some examples here. So here the first one, IP address. First IP address according to this example 111.56.045.78. Is this a valid now IP address? Anyone can answer. Is this a valid IP address? Anyone can answer this. Try to answer this question. Is this a valid IP address? How many of you are here? So left. So this is not at all a valid IP address, because an IP address where one of the octet is not starting with 0. Sorry, it should not start with a 0. Okay, so it is not a valid IP address. Coming to the 221, okay, dot 34.7.8.20. Is this a valid IP address? No, it is not a valid IP address, because we have 32 bits where 4 octets will be there, but here 1, 2, 3, 4, 5 are there. So it is not at all an IP address, valid IP address. Now coming to the next one, 75 dot, okay, 75 dot 45 dot, third one 301.14. So you observe here, what is the maximum number which is available in any octet? The maximum number which is available in any octet is 255. But you observe here there is 301. It is not a valid IP address. Okay, it should be less than 255. But here 301 is there. So it is not at all a valid IP address. Now coming to the next one, see the last one, that is 111.000.10.14.67. So what we are trying to do here, see this is binary representation and this is dotted decimal representation. We cannot mix them. We cannot mix both type of representations in one IP addressing. So this is also not a valid IP address. Mixture of binary and dotted decimal will not be allowed. Okay. So according to the IP addressing, IPv4 addressing, there are different classes are there for us. What are those classes? A, B, C, D, E. So these are all called as classful addressing. So what are they? A, B, C, D, E. These are all called as classful addressing. Okay. There are 5 classes according to IPv4 addressing have been made. So all this IABCD is all called classful addressing. So you observe here in this diagram, in this picture of PDF. So what is this here? Whenever we consider, in the lab session I told you about this explanation, whenever I consider one bit out of octet, that is 1, 2, 3, 4, 5, 6, 7, 8. If I consider one bit, how many divisions can be made? So totally 2 divisions can be made. So if I consider this bit, so that is class A. If I consider only one bit, it is class A of first octet. Okay, that will be the 0 here. Next, what about if I consider two bits, that is 1 0, this will be fixed for the first octet. This is class B. Now coming to the class C, if I consider 3 bits, so of first octet, so there are remaining octets are also there. You observe here there are yellow colors which are denoted here. So what are these yellow colors? So class D is, coming to the class D, 1 1 1 0 out of first octet. Remaining 4 bits are also there. Coming to the class E, what will be there? All ones, 1 1 1 1. This is about first octet. Coming to this one is second, third, fourth. This is second, third, fourth. So what is this? This is in yellow color and this is, sorry, this is in yellow color and this is in yellow color. Coming to this is in yellow color and this is in yellow color and this is in color, and there is no yellow color over here. Okay. So why these yellow colors have been used inside these boxes? So according to class A, 8 bits are used for network IDs. Here 16 bits are used for network IDs, and here 24 bits are used for network IDs. So remaining all of them are host IDs. So according to class D and class C, there are no classifications have been made regarding network IDs as well as host IDs. So there is no particular network ID or host ID are available according to class D and class E. So let me show you what are the ranges which are available. So coming to this, the ranges of different classes, I already discussed this. The network layer, it is 0 to 127. Now coming to this class B, 128 to 191. Now coming to the class C, 192 to 223. Now coming to the class B, the range is 224 to, sorry, 224 to 239, and class E is 240 to 255. So this is what happens here. This is the range which will be used. And one more thing, in every classes, class A, class B, class C, class D, or class E, IP addresses of starting IP address and the last IP address will not be used. Yes or no? The starting of IP address and the last IP address will not be used at all. So they will be used for different purposes. So according to the class A, how many is 128? But 0 to 127 is 128. Out of 128, will not use two addresses. So what will be there? 126 IP addresses will be available for us. Okay. So this is what happens here. 126 IP addresses, sorry, network IDs, not IP addresses. Network IDs will be there. 126 network IDs. Okay. So this is about this diagram explanation. Now coming to the next. Yeah, I want to discuss this one, important. So what is this? According to class A, first bit is fixed 0 and remaining 7 bits will be all ones. Yes or no? If I consider all ones, what will be the value? 128. Yes or no? 128. 128 will be there for network ID. How many? This is 2 power 8. Now coming to the 2 power 24. These are host IDs. So how many host IDs are possible? Here you observe here there is number 16,777 comma 216, not 16,000, 16 million. So this is what these many host IDs are available for each network of this 128. Okay. Let us say that this is 1, 2, 3, 4 up to 128 for each network. How many host IDs are there? These many host IDs are there. Okay. So what is happening here? Lot of host IDs have been assigned. So what is the problem here? One of the disadvantages is some of the IP addresses will never be used or hard to maintain these IP addresses actually. These many IP addresses are hard to manage and control them. So according to the class B, coming to class B, how many IP addresses are there? How many bits are considered? 1, 0. Remaining 1, 1, 1, 1, 1, 1. 2, 3, 4, 5, 6, 7, 8. So how many? Let us say that 2 power 8. Sorry, 2 power 16 will be the network IDs. Okay, 2 power 16 will be the network IDs. And remaining 2 power 16 will be host IDs. So 65,536 will be host IDs. Out of 2 power 16, we have only 2 power 14. So 2 bits have been already considered. Remaining are 2 power 14 network IDs are there. 2 power 14 network IDs are nothing but 16,384. So one starting from 1 to 16,000 up to 16,384 network IDs. So each network ID will contain 65,536 host IDs. Okay. Okay. We will continue this class in the next class. Up to this now. Thank you. Thank you, one and all.